welcome back to SK Kids, and we are back again with a new video. And today's video is really a special video because I consider it a very special video because the topic is about my experience studying physics. This is really because from days to days many questions have been coming to me from my elders and even my youngers that how did I start studying physics and how did I come to this much about learning physics. So I thought to just make a video and upload as a content on YouTube. So basically the day has come. I'd like to share about my experience studying physics. How did I really learn physics? How did I come in physics from nothing to something? I had an approach to physics. So basically I would like to share here my experience that how I started first of all learning physics. Then I would start from 4th class. Okay, in 4th class basically I started learning physics. Although as learning physics in a random manner, sometimes just like first of all I would study electricity and magnetism, then coming to friction, and then Newton's laws of motion, then to kinematics. I was studying physics in much like a random manner, in a random position. That not going in a systematic manner as first of all the mathematics required for physics, and then to go through all the kinematics and vectors, and again kinematics and 2D and 3D, and then coming to laws of motion. No, I was not going in that manner. And I'd like to tell, here I have the copy of first book of physics that I really read, A Brief History of Time, From the Big Bang to Black Holes by Stephen Hawking. Professor Stephen Hawking was the location professor of mathematics at Cambridge University, which I myself want to be actually. And this book was really very awesome. Here we have, actually I had got it in 4th class and now I am perhaps in 6th or 7th class, although due to the COVID-19 I wasn't eventually promoted in the 6th class, but perhaps I'll be going in 6th or 7th. I'm not quite sure about that. So this is a few years earlier, not a few, this is just like 2 years happened, perhaps 2 years happened for this book. And really I still keep this copy, and whenever I have any doubt in physics I really come to this book, and then when I really come to this book my doubt is finally cleared. It has cleared my many doubts, in fact my whole doubts from this book, and this deals with all kind of physics. All kind of, in just something about 217 to 18 pages. I'd like to show you here. Here's 219, here's 220th and 221st page. In 221 page, this book covers all kinds of physics from Copernicus, from the Plato and Aristotle and Ptolemy and Copernicus, to even Galileo Galilei and Sir Isaac Newton, and to Professor Albert Einstein and Professor Niels Bohr, and to Hawking indeed himself. This book covers all kinds of physics developed, and it also deals on the physics that is being developed, and also deals on the physics that will be developed further in our future, in our next generations. This book takes us from the Aristotle's assumption that the earth was a sphere rather than a flat plate, starting the topic with the same, starting the physics with the same topic, and it takes us to curved spaces and to quantum reality, quantum theory of gravity. It indeed takes us even to a string theory, that how can we really understand the string theory. So basically this was really a very good book, a very brilliant book by which I started learning physics just as I was in 4th class, and I finished the book very soon, I just remember, and from then I have fallen in love with really the physics. I continued then because actually from then I wasn't studying mathematical physics after all. I wasn't studying because mathematics is really complicated. Physics becomes complicated when it comes to equations and numbers and mathematics. And if we talk about modern physics, it is really very complicated for us to understand, and it even goes beyond philosophy nowadays to understand physics, to do physics philosophically entirely. And even I quite remember that the time when the science had become computerized and it was all of machines, when there was nothing left in science to be discovered more and more. I would like to say Professor Hawking has had, even in that kind of time, done great researches in physics like Hawking radiation and many more kinds of researches. So it's been great. So I want to be just like him because he was location professor of mathematics, as well as I want to be the location professor of mathematics, and I'd be very glad if I really become the location professor of mathematics. So basically, as I moved forward studying physics, I did really consult physics textbooks at first, and if I also consulted any hardly, I didn't really try so much of mathematical equations present and the numbers present in the textbooks. That's why textbooks are quite complicated in comparison to the popular physics books that I just have here. Many are present here. So I continued studying physics in more like popular physics books. Here's general reading. This is also 6 easy pieces by Professor Richard Feynman, who is known as the Great Explainer. And I always declare this book. This and A Brief History of Time is this book also, without the use of equations, it explains much of physics. Actually, this has been derived from the Feynman lectures on physics, because when Professor Richard Feynman went at the California Institute of Technology at Caltech, then from 1961 to 1963, he delivered a series of lectures there, which were summarized up in Feynman's book, The Feynman Lectures on Physics. You can call the best books on physics, which is considered as the Bible on physics, Bibles of physics. But if we directly start from the Feynman lectures of physics, I don't say Feynman lectures of physics are not good. I say that those are the best lectures on physics, the best textbooks on physics you can ever get. But if you quite start from the Feynman lectures on physics, so you will be stuck in physics as complicated, because he describes everything from Newtonian mechanics to quantum theory. So that will become little complex because they are treated something like textbooks. But from there, in this book, 6 easy pieces by Richard Feynman, again 6 chapters, 6 easiest chapters from Feynman lectures have been Feynman lectures on physics have been taken. And those are something like atoms in motion, basic physics, the relation of physics to other sciences, conservation of energy, theory of gravitation, and quantum behavior. 6 easiest chapters and have been put in this book. So it would be really good if you want to start physics from a very low level, from easy level, and then you have to move to the high. So you should start with something easier, popular physics book. And when I would say that this is really good, 6 easy pieces by Richard Feynman. As I continued next reading, I kept reading such kinds of books, and even 6 not so easy pieces, some that is more about relativity. In this, there's been explained about atoms and quantum mechanics, more about relations, what's the relation between sciences and each other, but that is more about relativity. So if you have learned physics a little, so you can go for 6 not so easy pieces. Otherwise, if you really are not from a science background student, so that's not really so good, as much will be like A Brief History of Time and 6 easy pieces. That is also a really great book. And I've been kept reading books like this, and one of the books I really love, I really didn't start it reading when I was in 4th class, but I have read it recently. For the Love of Physics by Professor Walter Levin, and really it's been a great reading Professor Walter Levin's book, because I would like to say he's the professor, he actually was the professor at MIT, I mean Massachusetts Institute of Technology, and which is considered the, you may call it is one of the best physics institutes, technology institutes in the entire world, on the planet, on the globe. So basically he was a professor at MIT, Walter Levin, and currently from my point of view he is the best professor of physics. I always watch his lectures and it's been great. Even watching his lectures, he explains very quite different things and very interesting things. And this book, you'll really fall in love with physics. If you don't understand physics, you should go with this book. And if you understand physics and want to learn more, then you should go with this book. So either way or any way, you may call any way, okay, any option if there is. for physics, if there's a a word of physics, you must go from this book, whether you like physics or dislike physics. If there's any relation, whether that is of liking physics or disliking physics, you must go from this book. And if you dislike physics, you'll really like physics, and if you like physics, you'll really more and more like physics. Okay, so the sentence was quite complicated, but yeah, this is really good book. And I'd also like to say that Professor Walter Levin had also commented replied, because my father had sent my one video link to Professor Walter Levin on his YouTube channel, so he had also replied, and that was just great experience. I'd like to share my experience about that I was just sitting here in my room, and my sister was actually sleeping. Okay, because I'd slept that day very early. I'd been got up whole the night the previous day, so that day I'd been sleeping early. So as Professor Walter Levin replied, instantly, directly my father came and opened the door and started shouting. It was something like any great moment came, or any great accident, any accident occurred, any bad moment has come. He started shouting that way, and then he started crying that Walter Levin has replied, Professor Walter Levin has replied. So that was really great moment for me. It seemed that I'm just still in dreams and I'm dreaming. So when I get up over, that would be the real condition. But I wasn't dreaming at all. So it was great. It was really a very great book. As I continued studying physics, this book recently I had read. Okay, and nowadays also I'm reading some books on string theory particularly. I'd like to share my today's experience. I'm trying to study and understand string theory. So I picked up a book, The Elegant Universe by Brian Greene, Superstrings, Hidden Dimensions, and the Quest for Ultimate Theory. And this is really my topic of interest. I want to get into the field of ultimate theory. I'm really very sorry for just a little bit of time. The electricity was gone, and as we're living in a remote village, so there's a very big problem of electricity. So coming back to our point, this book is really very special book by Brian Greene, The Elegant Universe, Superstrings, Hidden Dimensions, and the Quest for the Ultimate Theory. To understand string theory. Now I like to be truly speaking of, all time just say that I could never actually understand the string theory. It was very complicated and difficult for me to understand string theory. I've been never able to understand it after all. But just after I read this book, I am sure that after completing this book, I really understand string theory, because this book, in a very simple manner, takes us from the Einstein's general theory of relativity to Planck's and Bohr's quantum mechanics and to the string theory, and finally gets us in a deep dive to the string theory, that how to really understand string theory, what is a string theory, and how is matter created by the vibrations of tiny strings, or by which the quarks are made up of. So this is really a very special book. I've been reading it today, although I had started the book today. Today I have started the book, and I have also read much. So I'm quite sure, I really have the confidence after reading this book. My knowledge about physics will be gone really in a very upper in comparison to today's level. So this book is also really very special book, particularly about string theory. As a whole, string theory is reunification of all the theories in physics. It is really, because whatever theories there are, like general theory of relativity and quantum mechanics, string theory unifies both the theories, but could not be proved experimentally till the date. And even that's why some physicists and some professors of physics even question whether string theory is physics. There's been questions about that, is string theory really part of the physics, because it wasn't be able to prove experimentally at the time, but perhaps in the future generations will be able to prove it. And then if we can do that experimentally, so string theory will be really proved as the ultimate theory of the universe, as the theory of everything, the complete unified theory. So that was my experience with all those popular physics books. Okay, some of which I had been read very early, like A Brief History of Time by Professor Hawking and 6 Easy Pieces by Professor Richard Feynman. And there's been some books that I am quite reading at the moment, like For the Love of Physics by Professor Walter Levin, and The Elegant Universe by Professor Brian Gray, and even there's been also a book named as Quantum. Quantum, Einstein, Bohr and the Great Debate About the Nature of Reality by Manjeet Kumar. That was also really very helpful book, but that introduces quantum mechanics in a historical manner, in a series of events. So if you really want to get quantum mechanics into here, right there in your head, so you can use it in a historical manner, because if you want to learn quantum mechanics in a conceptual manner, that would be really difficult to understand the subject with that great difficulty. It really has a very high level of difficulty, quantum mechanics particularly. So if you try to learn it in a historical manner, that would be easier, and same is done in Quantum book by Manjeet Kumar. So that is also really very helpful book, although I don't have it here right now. It's been in my home, somewhere else, perhaps in the other room. So I have here all those books, and I would like to also introduce. Later, what happened next, when I started really learning physics from the 4th standard, I also went to the 5th standard. When I passed out 5th standard, my passion towards physics became extremely high, and I really required time. In fact, to study and understand the laws of nature, because I really always wanted to understand the workings of nature. How does the nature function? How does it work? And why does the nature work in the way it works? Why do the events occur in the way they occur? Okay, suppose something of common example, that if I try to always understand, if I write something here by this marker, so why does the marker write? Instead, why doesn't it erase the ink? Okay, why does the camera shoot something, and why doesn't it delete or some other image? Why can't the other process be possible, that if ice is melting, if we are giving heat to the ice so it melts, isn't it possible that we give heat to the melted water and it becomes ice? So I always try to understand the workings of nature, and there's been a why all into my head, that why is this thing? And if I get the answer, there's why again. Because that is a real method of learning. If you really want to learn something, you need to question about the thing. That what, how, when, where, and why. There are infinite questions that can be developed into any subject. So you need to develop them, and you can really learn a subject. So I always try to understand the workings of nature, that why the stars appear at the same position they appear. Do they move in fact? Do the stars really move, or they stay in the same position? How big would be the universe, or how big would be the universe that we can only really see? Or perhaps there is the universe which we cannot really see. So there's been all these questions in my mind. So after lockdown, due to COVID-19, I really got a very brilliant opportunity to study physics. That was really very brilliant opportunity. Then I tried to, what happened, I like to give my experience, that I was also reading English novels particularly. During the beginning of lockdown, I was reading novels of English. Some of the novels I like to name, like Alice's Adventure in Wonderland by Charles Ludwig. That was really very good. And Invisible Man, that is also science fiction by H.G. Wells. So such kinds of novels like Shakespeare's and Marlowe's and all those kinds of novels. So I also really loved all of them. But later what happened? Then my interest actually came into mathematics, and that was helpful, because if that wouldn't be the day, so perhaps I wouldn't be speaking of anything before you. Because what happened, that our father was just making us sit and giving us some lecture, that actually what you want to become. If you really want to become, just like I would say I would become a scientist, my sister would say she wants to become an IAS officer. So what you want to become, you'll have to work hard more and more. If you want to do something special, so you need to do some special work. And that sentence has been really helpful in entire study of my physics as well as mathematics. Okay, suppose it is imaginary here. Okay, here's physics and mathematics, it becomes then. You may suppose that here mathematics is written, you may just suppose, and it is giving some infrared radiation, so your eyes aren't able to see. Okay, just kidding. Now, what happened then, from that day my sister started studying mathematics very seriously, and later my sister's interest came back into mathematics, and I started learning physics. since physics really, in fact, requires mathematics. You cannot always do physics without equations. Equations will be helpful. Mathematics and numbers will be helpful. Then my sister called me and said, let's solve maths together. First of all, I questioned her. She was going to solve the 9th NCERT mathematics. So I questioned her that I am just at this time 5th passed out. I just can't understand what you are doing. So I was questioning her, but she said, you can really do. You have the capability. You have the ability to understand physics of Hawking and Feynman, Levin and Greene. So you can also do this. So I just sat with her and I continued to do, and in a very little time, as like in a few hours, I began learning it. In some few hours, I learned the methods I was doing, and I just then continued. I just got interest into mathematics, and I did more and more mathematics. And then what happened? I also solved some more books on mathematics, like 9th R.S. Agarwal and 10th R.S. and R.D. Sharma. So later what happened? I solved some more books and even some chapters of 11th. Although there's still confusion in some mathematics chapters of 11th and 12th, but I'll just manage it. I'll do it again. So from then, now my mathematics was good enough to start from a textbook. Now I really had the maths that was enough for me to do the books of class 11th and 12th physics. So I decided to pick up a nice book, and this book I like to truly be showing off. Here I have the 2-volume Concepts of Physics written by Professor S.C. Verma, who was actually HOD at IIT Kanpur, Department of Physics, and this book was really very helpful for me. Here are the 2 volumes of this book. Here's the first volume of this book, and the next I consulted was this volume, the second volume. Those are of 11th and 12th respectively. The first deals with 11th syllabus, while the second with 12th syllabus. Now this is a textbook. This is for something like JEE and NEET preparation. This book was given to me by my uncle, Hasib Chatu. I always tell this. He had given me this book because he saw that I really had a deeper interest in science. So he thought he should be giving me this book over physics. And when he gave, first of all, he said that he still perhaps you don't have the mathematics enough. If you can't understand mathematics, that will add this level which is required for it. You can go just with its theory and then just can do for your interest in science. But when I did my maths with my sister, who is really very helpful for me, most helpful for me to understand maths. My sister really taught me maths if I talk about mathematics. So my teacher was really my sister. For mathematics, the credit goes to her. I didn't take any coaching, any tuition. But although my sister taught me the mathematics, so indirectly she taught me physics. Because if she teaches me mathematics, that means she just taught me physics. Later what happened, then I also started solving the numericals of this book. That is quite surprising that I am doing the numericals of 11th and 12th class physics. That was really great moment. I remember when I first time solved a numerical. I just remember when I first time solved physics numerical. So that was great moment for me after studying the theory and enough mathematics. So that was great, really very great moment for me. Then I continued to learn physics and I consulted some more authors for particularly 11th and 12th syllabus, because as much as I can go for the knowledge in physics, I can just develop it. That would be better for me and my interest towards physics. So after Professor H.C. Verma's book, Concepts of Physics, I also went to D.C. Pandey's book, Understanding Physics, which comes a set of 5 volumes. So it's quite fatter and it's quite, you may call, more volumes up. So I went through that. I loved those volumes. And then I finally went to another foreign author book, Resnick, Halliday and Whatcom. Basically, the Fundamentals of Physics, internationally accepted version comes, but all the fundamentals of physics isn't sold here. I went through Resnick, Halliday and Whatcom, who were great professors and physicists. Principles of Physics. There's not much difference between fundamentals of physics and principles of physics, but very minor. So I went through Principles of Physics. Now I really loved the subject a lot, even at its mathematical level. Now not only understanding the books like this brief history of time, Feynman, and for the law of physics and Brian Greene, I could also understand the mathematical equations of physics, and that was really great. And if I was able to do it, then there was really a chance I could achieve my ambition to be a theoretical physicist. So I started doing maths, and from then up to now, during the entire lockdown, I studied only physics and mathematics. Didn't remember about my schools, didn't do anything special for my schools. Yep. And today the day has come when I learned enough for delivering all of my experience of physics towards you. So that was all about my experience about physics. Basically, now in the end of the video, this was actually my experience, how I study physics. I'd also like to give some tips about how to study physics, starting with branches of physics. Branches of physics you may define. There are two basic branches. I always tell that physics you may call is Newtonian mechanics, first of all, then optics and modern physics, and Gibbs and thermodynamics, but you can leave all of them. But give to the classical physics and modern physics. It is the only. Classical physics and modern physics are the only branches of physics. It is classical physics you define as the physics before 20th century. What physics was there before 20th century? That of Aristotle, Plato, and Copernicus, even Sir Isaac Newton, who had done great development into even modern physics. All the modern physics lays on the foundation of Galileo Galilei and Sir Isaac Newton. So, all those physics is said to be classical physics. While the other is modern physics, the physics of during and after the 20th century, and in which the developments have been still going on and will be still going on, and will be forever just going on, because modern physics deals with something more complicated than the classical. Classical physics deals with the wave theory of light, and then particularly particle theory of light. If we talk about wave theory of light, that is under classical physics. Particle theory of light, then that is under classical mechanics or just classical physics. But if this is about wave particle duality, so this is really modern physics. This comes the modern physics. Means particularly they were classical, but when we unify all of them, so it becomes all about modern physics that lays on the foundation of quantum mechanics. So that's really complicated. We'll be coming on that later. So this is, if you want to learn physics, you must be starting, as I would like to say that as Feynman says, Richard Feynman, Professor Richard Feynman, the great explainer, that we cannot start the subject without a map or outline of the subject. In his book, Feynman Lectures of Physics, Feynman describes that we need a map about physics. We need to first of all understand about what is physics, why is physics, how is physics, and what is in physics. And he also says that to directly start with the correct things is inappropriate, because if you first of all, he also exemplifies. I really have loved his book a lot, that's why, and he explains everything, very difficult concepts in a very simple manner. So I like to say from there that Richard Feynman says that earlier a law was invented. Since any spinning top has the same weight as a still ones, so a law was invented that mass remains constant independent of speed. But today this law is found to be incorrect until we do not move to a fraction or to the speed of light. This was by Einstein something. Professor Albert Einstein said in his special theory of relativity that mass increases with the increase in speed or increase in velocity. So basically, philosophically, we are something like wrong. When we predict anything directly theoretically, we come to be wrong. But basically, we can just see as we approach to the mathematics, we come to the correct things like Einstein's special theory of relativity instead of the simple constant mass law. But if you directly start with the correct law, that is the Einstein's special theory of relativity, space-time, Einstein's general theory of relativity. So the things become quite complicated because even the terms which are used in those theories, they are very hard to explain without understanding the classical physics. So if you really want to understand physics, first of all you have to go with the mathematics, enough required for it. Then you'll have to go with classical physics, which will introduce the terms in a good enough manner, and then you need to go to modern physics if you really want to make your career in physics. And as you do modern physics, you need your own thesis for something like PhD, and then you can get a professorship at any university, and then you can become a scientist or professor of your will, just like Professor Einstein, Professor Levin, Professor Hawking. And I myself want to become a professor of physics as well as mathematics, because I really want to become the Lucasian professor of mathematics. So if you really want to make your career in physics, you need to choose a good manner. So from my point of view, you need to go with maths first of all, then the classical mechanics, which you may call as a whole classical physics, Newton, in which has contributed most of all from my point of view, and then you need to go through modern physics. And to study physics, I'll again say that selection of right books is most important to study physics. If you choose books in a random manner, any book you are getting in a market, that wouldn't be really good. Then to choose a particular book, but a very special book, you need to choose a very good book. I don't say that what I see they study like Rustic Halliday and DC Pandey and Siboma. I don't say that if I say to you just follow those, then perhaps those are really not good for you. So whatever books you are selecting, select a good one, select from educated and what you are comfortable in. Don't follow any book blindly that you are not comfortable, you are not quite able to understand, and you feel the language is quite different and complicated. Select the book which you can really understand, and if you can understand some particular type of book, then you can really do physics in a good manner. So that's the all, and for all physics, concentration is important, much interest in learning is important, concepts are important. And I would like to say in the end of video, if you really want to forget everything I told, the most important of all is hard work is important. And if you also